In this video, we will show you the basic of functions. Beginning with the definition, a function f from set A to a set B is a relation that assigns to each element in the set A exactly one element in set B. As you can see in this example, set A is on the left side and set B is on the right side. Notice that in set B there is a repetition of elements here, but there can be no repetition in set A. Writing a function, we input Omar as a student and we get F as the output, or the grade, which would be set B.
Function rules, part 1.
So this is a function, f of x equals 5x plus 2. So we're going to plug in for x a number. So it would be f parentheses 4, and then we would bring down the function and plug in 4 for the x, which is equal 5 times 4 plus 2, which gives us 20 plus 2 equals 22. And then the other one, we would plug in a variable. In this case, we would plug in k. So 5 times k plus 2, which gives us 5k plus 2. And in this one, we're plugging in an expression, x plus 4. So, which would give us 5 times x plus 4 plus 2, which gives us 5x plus 20 plus 2. Then it gives us 5x plus 2.
Function rules, part 2.
Using this function as our current function, we will plug in a number, a variable, and an expression. In the first example, we will use 4 as our number, and we will replace it with every x we have. So it would be 4 squared plus 2 times 4 plus 5, 16 plus 8 plus 5, which gives us 29. For the variable, which in this case is m, we will just replace the x's with the m's, which would just easily give us the same answer with a different variable. For the last expression function, we will use an expression, and we will replace it with the x's, x plus 4 squared plus 2x plus 4 plus 5. And since the expression is squared, we will not distribute the square, which would make it x squared plus 16. We are using FOIL, which is multiplying x times 4, x plus 4 times x plus 4. When we FOIL it, it gives us x squared plus 4x plus 16. And then we distribute the 2 to the x plus 4, which is 2x plus 8. And we just give the plus 5. And then after that, we combine like terms, which gives us the answer of x squared plus 10x plus 10. When graphing a function, there are certain main characteristics that tell us whether the function, whether it is a function or is not a function. Some of these include the vertical line test, which works for this because it is a function, since there are no repeated x's, but it does not work for this one because there are more than one x's. The other main characteristic is finding the roots or the zeros. For this one, it's very easy since it's 0 at the origin, and to find the root, you need to make y equal to 0. So if we made this, it would be 0 is equal to x, which would be the root with its origin. For this one, when we set it to 0, since it is not a function, x squared minus 1, we add 1. Hold on, I think it just did this wrong.
No, keep going.
Okay. 1 is equal to x squared. Take the square root. X is equal to the square root of 1. Is that right? It's not right, is it?
I think it was plus 1.
Damn it, Miguel! Hold on. Alright, do it again, guys.
Okay, serious.
In this function that is not a function, to find the x's, we need to set y equal to 0. Plus 1. Subtract 1. Negative 1 is equal to x squared. And we take the square root. But there is no square root of negative 1. It would be imaginary. Therefore, it's not a function.
piecewise function. A function defined by subfunctions on separate intervals. The function of x could be x squared plus 4 and x minus 2. X squared plus 4 if x is less than 0, and x minus 2 if x is greater than or equals 0. Here are some examples. If we plug in negative 2, which negative 2 is going to be in the condition of, since negative 2 is less than 0, we will plug in this function into this example. So it will be negative 2 squared plus 4 equals 8. In this example, it's 4. Since 4 is greater than 0, it will be 4 instead of x minus 2 will equal 2. And if we plug in 0, which is 0 equal to 0, we plug in this function, which will be 0 minus 2 equals negative 2.